In section 1.3, we're going to be learning about trigonometry. If you know the certain combinations of side lengths and angle measures of a right triangle, you can use ratios to find the other side lengths and angle measures. So we'll use this rather than the Pythagorean theorem when we're given a combination of sides and angles. So let's say we have right triangle ABC. The sine of A would be if we're anchored at angle A, and that would be the opposite side over the hypotenuse. So let's talk about what those are. So we're at angle A. The opposite side would be the little a right there. That's our opposite side. The hypotenuse, as we talked about when we did Pythagorean theorem, is always going to be that longest side, so side C. So if I wanted to find the sine of A, that would be opposite over hypotenuse, which is A over C. The cosine of A would be adjacent over hypotenuse. Adjacent is a fancy way of saying next to. So the side or leg that's next to angle A is B. So we're going to say that the cosine of A is adjacent over hypotenuse, or side B over side C. Finally, the tangent of A is opposite over adjacent, so that's going to be A over B. Now, this might seem kind of weird right now. Write this down in your notes. This might make a little bit more sense when we do an example problem. Another way to quickly remember this is the acronym SOHCAHTOA. SO stands for sine is opposite over hypotenuse. CA is cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So in our first example problem, what are the sine, cosine, and tangent ratios for angle T? Here we're not really using our calculator at all. We're just working with finding those ratios and working on that skill. Anchored at angle T, sine again would be opposite over hypotenuse. So I look opposite of that angle, I see 15. 17 is my hypotenuse, so our answer here would just be 15 over 17. The cosine of T would be adjacent over hypotenuse, which here would be 8 over 17. Finally, the tangent would be opposite over adjacent. Now that we have everything labeled, this will be pretty easy. Would be 15 over 8. And that's it. In example number 2, we want to solve for x. So now we're actually going to be using algebra here and actually finding a side length. We want to round to the nearest tenth. Notice here that we can't use the Pythagorean theorem because we have too many missing side lengths. But since we were given a combination of sides and angles, this is where trig can be helpful. I'm anchored at 40 degrees and I want to label what x and 10 are in relation to that angle. X is my opposite side, 10 is my adjacent side. It's adjacent because it's a leg, it's not the hypotenuse. So that's why we call it the adjacent side. It's touching the angle and it's not the hypotenuse. So I'm going to use tangent here because that uses opposite over adjacent. Tangent of 40 is O over A, which let's replace that with x over 10. From here we want to solve for x. Right now we're dividing by 10, so let's do the opposite. Multiply by 10 on both sides. And when I plug that all into my calculator, I would do 10 times tangent of 40. I'll show you how to do that in class. We would get 8.4. Now let's look at another example. I want to solve for x again. Anchored at 30, I see that 6 would be my opposite side, and x is my hypotenuse because it's that longest side across from the right angle. So to set that up, I do sin 30 equals O over h, which is 6 over x. Here we have our x in the denominator, but that's okay. We're still going to work with it like normal. To get it out of the denominator, let's multiply both sides by x. Those cancel. Now I'm left with x times sine 30 equals 6. To get x by itself, I'm going to divide both sides by sine 30. I'm going to do that all in my calculator. When I do 6 divided by sine 30, I get 12. Now, we're solving for the angle. We're going to do the same process here. It's just going to be something a little bit different in our calculator. Anchored at x, I still want to find out my relation with 8 and 17. Here I can see that 8 is my adjacent side, 17 is my hypotenuse. So I'm going to write this as cosine of x equals A over h, which would be 8 over 17. Here I'm going to press like an inverse trig button in my calculator. So I'm going to press, and again, you'll see how to do this in class. It'll say cos negative 1, 8 over 17. That whole thing's going to go in our calculator, and we're going to get 61.9 as our answer.